Welcome to writing formulas for type 1 and type 2 compounds. This will be a riot. Huh? Right. Okay, never mind. I'll try to make it entertaining. Absolute cosmic rule. An ionic compound's charge always adds up to 0. Always. Take sodium chloride for an instance. See, sodium has a charge of +1, and chlorine has a charge of -1. And if I add those charges together, I get 0. Absolute cosmic rule. Writing the formulas is somewhat painless, and we've done a little bit of this already. First step, write the ions. So the ion for calcium is, there you go, and chloride. Do those charges, the charges, I'm even going to circle them to emphasize my point. Do these charges add up to 0? No, they don't. So we are going to add coefficients to this system so that we do get the charges to add up to 0. And we're going to use a mathematical concept called the least common multiple. Let's see, what number times 2 will give us 2? Well, that one's easy. Okay, now this is -1. So what number times -1 can give us -2? Easy. Now we're going to add in some chemistry symbols. Lastly, you write the formula using those coefficients for subscripts. I just want to make one change to this formula, just one. Ignore the ones. Booyah! We're done. Right for a type 2, just a little different, but not a lot. First, write the ions. Please remember this. If you please remember this. Sorry, I shouldn't sing. Okay, anyway, remember this. See that +3? Where did I get it? Yeah, it's this thing right here. It's that. That +3 is never, ever, ever, never, ever, ever, never, ever the subscripts in the formula. Never, ever. It's the charge. Okay, now that we've got that done, the same rules apply as just as before. You're going to add coefficients so the charges add up to 0, using the least common multiple. Because 2 times +3 is -6, and 3 times, I'm stupid, yeah, that's +6. Let's try that again. 2 times +3 is 6, and 3 times -2 is -6. Now the charges add up to 0. Now we're going to write the formula using the coefficients for subscripts. And since there's no ones, we're done. Next, we're going to start using those polyatomic ions.